So example 1, as the string equals leet code, and word dictionary we have the words leet and code. As you can see, we can separate it here after the T to separate this whole string into the words in the word dictionary. That's why we return true. Second example, apple, and then pen, and then another apple. The word dictionary contains apple and pen, and because it's the same word in the dictionary may be reused multiple times, so we also return true because apple, pen, apple can be segmented as apple, pen, apple, and we're allowed to reuse a dictionary word. And example 3, cats and OG. So the word dictionary contains cats, dogs, sand, and cat, but we have cats and we don't have the word OG, and we can't have any like extra random letters in our as string. That's why we return false. So we can solve this question using dynamic programming. I'll use the cache, the Python memorization decorator, and we'll define our DP using I. The state is I will be the index of the string. And our base case is if I goes below 0, because and the index can go down to 0, right? So we don't have to write equals 0. If it just goes below 0 and we haven't returned false, then we just return true. And because we want to check that everything in that segmented is a word in the word dictionary. So then we can start writing our recurrence relation for word and word dictionary. If as I minus the length of word plus 1 to I plus 1 equals word. Okay, so let me kind of explain this statement. So in the string, so first of all, we will feed dp, let me write the end thing, return dp length of s minus 1. So if, for example, our string is leet code, it has 8 letters, right? Length of s is 8, and we want a minus 1 because we start on 0 index. So it actually goes from 0 index to index 7 here. And then we want to check that if starting backwards from I minus length of word, the first word is leet, right? And the length of word is 4. So 7 minus 4 equals 3. So on our third index, 0, 1, 2, 3 is actually T. And we want to plus 1 to make it equal C because we want to check if code equals leet. And then so we want to do plus 1, so it starts at C, and then we want to do till 7, index 7, but as you know, if we're using this S index colon this, it doesn't actually include the last index 7. If we don't do the plus 1, it will just be till index 6, so we have to do I plus 1 to include the last index. And then if this equals word and all of the other DP recurrence we check going down, let's say this one equals word and S. Length of S, no sorry, it will be I minus length of word. So then we have to minus this word off our index. And next time this index comes in, it will be 7 minus 4, which is 3, and the ending letter should be at index 3, which is T. Yeah, and then if this is true, then we return true, and otherwise we return false. And this is the entire solution, and the time complexity will be, sorry, give me 1 second. The time complexity will actually be the length of the string times the length of the word dictionary times the length of the average word in word dictionary. And the space complexity will be just the length of S. Yeah, so this is my solution, and let me know if you have any questions, and thank you so much for watching.